weeded out schools too. As I said, I don't like this person. She's the only one that I would work with now. Yeah, I don't know. I guess I was going based on both chemistry and personality. You know, if I felt like I could work with someone and not feel stupid asking a question, that was really important to me.
So yeah, I picked my advisor solely on I was really interested in chemistry he was doing. I worked for a first year assistant professor, and so it was a really intense environment. And he ended up not getting tenure too. So during that time, it became really even more intense. And so grad school was pretty rough. I will definitely admit that. And we were much more under the gun than some of my friends in other groups. That being said, I feel like I got a lot more out of grad school than other people in more relaxed groups. I was not totally happy at the time, but coming out of that, I think I learned a lot more than some other people did. So it turned out to be a really positive experience in the end. Just can be really intense, especially with the first professor.
Yeah, I mean, I chose twice also. I worked for a chemical engineer. I got in the lab and I decided it wasn't an environment that I liked. And so, fortunately, where I was at, I was able to change groups, and that's really nice. That's a good thing to ask, actually, when you're at grad school meeting people, like visits. Ask people how often people change groups. Some places they change groups much more often than others. And if you're not sure about what you want to do, if you're like dead set, I'm gonna do this, and you're 100% sure, then that's not really very important. But if you're kind of, maybe you're interested in biochemistry and inorganic chemistry, or I don't know, physical chemistry, and I don't know. If you have the capability to kind of change and get into something, that might be a big advantage for you. And it was for me. I changed groups and didn't have much of a problem with that. And I worked for a very established guy, so it was a very different experience for me, but I felt equally satisfying because of my colleagues. My friends are very smart people, and I took advantage of that. So that helps.
Who else has questions?
So you say you're going for a master's degree because of the
No, I'm going for a PhD.
PhD,
But yeah,
because of the freedom of the future publication.
Well, I mean, just I guess this is kind of what people were talking about before. If you go into most, I guess, industries, and with only a bachelor's or a master's, you're kind of told what to do. You don't have a whole lot of choice, right? And with PhDs, you can kind of choose, and I'm kind of moving towards academia, where I'd be able to kind of go off on my own research path and have people work for me.
In the industries I've worked in, it's definitely a lot easier to kind of do what you want to if you have a higher degree. The reason that people with bachelor's degrees are doing the things that they are where I work is because they're really motivated and they really are putting in, way more hours than people with PhDs, and they're constantly being like, I want to try this. I'm just going to do it, basically. Whereas if you come in with a PhD and say, I got this backwards, it's basically, you've basically already proven yourself that you kind of know what you're doing. So it definitely makes it a lot easier. And in a lot of industries, you just can't advance past a certain point without a master's or a PhD.
So if you go into industry and you're working in like R&D type stuff, and you like come up with something really cool that you don't think has been done before, do you then go to publish a paper in like in JAX, or is there a patent process first, or like what happens if you discover something new?
The way my company would do it is you go to talk to the upper management, and first you patent it. You patent all your ideas or anything that could be a good idea, even if it might come into nothing in the end. And then you can start writing papers once your lawyers look over everything. The lawyers have to go over your papers before you publish, and then before you let any of this information go.
you know, we can't use patient samples without their informed consent for a trial. So we can use something to develop a method in-house, but it's not something we can profit from, you know, the sale of intellectual property or whatever.
Same for my company and our bioanalytical department. They will be doing assays on human samples for clinical trials and we can't publish that information.
A lot of companies like to hold on to their own ideas also. So if you publish it, then anyone can do what you published about, right? Anyone can read your paper and do your method, and it's great. But a lot of companies, like PerkinElmer, they like to keep it a secret so that they have an advantage over their competitors.
Yeah, we'll only publish for publicity. So the really cool result that will give us revenue, get our name out there, and we'll publish. But other than that, we won't do it, even though we have some cool results.
Academia is much more about prestige, you know, like what you've done matters a lot more. In industry, anything you develop is going to give you a competitive advantage. So you want to kind of keep control of it, even if it is something really great.
It's all about money.
Yes, along those lines, one of the things I wrote down was like, if you guys could comment on like the difference between academia versus industry versus government labs, that would be pretty useful.
Is that me or?
I
So I had the great fortune of experiencing all three. So, you know, I did my grad school and experience academia. I did a postdoc in a national lab, and now I'm in industry. I think the biggest difference is that box around what you're able to do. Obviously, academia, there is no box. You can do anything you want to do, any crazy idea you have. Most of the time, you can go to a lab and do it. No restrictions whatsoever. Industry, on the other hand, there's a box around you. So you're into the, you know, I can't just go off and make some random organic compound. I have to work on quantum dots, you know. And so you're very much more limited to what you can do. A government lab is sort of in the middle. So a lot of times you'll have projects going on that are very applied projects, and so there will be a box around you, but you still also have a lot of freedom to go out and just do random stuff as well. So it's kind of middle ground between the two. As far as your responsibilities go, like, and that's the other side of it, is like in academia, it's all on you. You know, you have to get your first few years, you have to get your funding, you know, it's all on you. You have to come up with the ideas. Government labs, again, more in the middle, where you definitely have to concentrate on funding, but a lot of times you do a lot more collaborative projects with other PIs, and so you form all these centers and stuff too. And so it's not totally on you to come up with all ideas. And then in industry, a lot of times there's more of a hierarchy, so you know, you're kind of given projects to do. So it just depends how much input you want to research.
I worked in a manufacturing lab, like I said before, so there was really no, sure, if I thought that an analytical method was it was not effective, or I thought I could resolve my HPLC peaks way better by trying a different method, then they would be totally up for me developing a new method. Or if I thought that there was a better synthetic route for making, acetone or something stupid like that, then they'd be like, sure, try that and let us know how it goes. But as far as making new compounds or something, there was no room for that, because you'd be wasting supplies and things and time and money, and so they weren't really up for that. But on the other side of that, they also have, at least in my company, they have all these crazy business models. I won't even bore you with the names of them, but they're all pretty much continuous improvement projects in order to save the company money in direct dollars, in saving solvent or saving packaging materials, or in indirect money in saving time and labor, or getting a higher quality product at the door so you don't have as many customer complaints or things like that. So there was a lot of creativity in that way, which is really not related to chemistry at all. My continuous improvement project was a process flow project. Turns out I'm really horrible at process flow analysis, and it didn't go very well, and I went to Aruba instead. And then I went to grad school, because I didn't really want to do as much business, as much flow charts and Pareto charts and, diagrams and pie charts and PowerPoints and, what you see on TV.
It's definitely a lot easier to pursue something in academia just because I think it's interesting, or it's something you want to do. Like in industry, you definitely have to be able to put a price tag on it and say, I want to do this because this is going to save us, $5,000 over the next 2 months or whatever. If you just say, I want to do this because I think it's cool and it might work better, but I'm not really sure, they'll say, well, you should probably be spending your time working on something else then.
Yeah, that being said though, academics are more and more being required to have definite applications tied to what they're doing. Because the funding for academics is now shifting a lot. It used to be, back when my old boss was an assistant professor, most of the money came from the government and the NSF. But as you guys probably know, the NSF is getting cut, the NIH is getting cut. Even the DOE is getting cut. And so the funding is coming more and more from industry for academics. And so a lot of times people who maybe have more fundamental projects in mind may have to massage what they really want to do so that they can get funding from the industrial companies. So you definitely have more freedom, I think, than you would if you were working for a company. But you still have to have some kind of, way to get money. And that's a big problem for academics, and I don't think that's going to go away. And I'm starting this job, so doom and gloom before I start on that's the reality of it. I don't want to be, certainly it's not all flowers and it's not like the professor just sitting on a tweed jacket smoking pipes and reading Shakespeare. It's about the Niels Alder reaction. So, a little different.
Well, that's the case in America, I think. Other countries,
Right. So if you want to go to Japan, it's a much different system. For example, Japan, it start out as basically a glorified postdoc as an assistant professor. If you want to go in Europe, you have a lot more flexibility, maybe like it was a long time ago. But those jobs are very difficult to get because the tenure process is much. I think there's no forced emeritus or there's no they last a lot longer. There's far fewer European jobs, I believe, than